Okay, good morning, everybody. So, this is what we did yesterday. We created a custom VPC and created two subnets, public subnet and private subnet. We made public subnet really public by creating an internet gateway and attached to VPC. And also created a custom route table and added an additional route to internet gateway for all the people from public subnet. So we associated that custom route table. We called it public route table. We associated that public route table to public subnet. That is how the subnet became public, really. And now the private subnet. So the private subnet is associated with the default route table, which has only one route, which is internal route. Okay, there is a route to all the pieces, all the components within VPC. Make sense? So we talked about CIDR range and created public-private subnets and created a couple of web servers in public subnet and created a couple of app servers in private subnet. And we were able to log into public subnet. And then we were not able to log into private subnet for obvious reasons, because there is no route out, right? So what we did was we logged into public subnet. And then from public subnet, we were able to log into private subnet using the private key. Meaning, what we did was we did some hacky way. It's not a good practice. Security architect will kind of security people will find it, extremely vulnerable. So you don't want to do that. But I showed you a way. So you have a private key. So copy the private key in your web server, and then using that private key, you can SSH into private subnet app server. That's what we did, right? So today, let's fix that problem. The one I was saying, the security guys will find it extremely vulnerable, right? So what we can do is, rather than copying the private key file into public subnet, into web server, what we can do is we can use something called bastion hosts. Bastion hosts are there's another name for that called jump box. Okay, so essentially it's a big name, but there's nothing there. So essentially, bastion host is nothing but it's an EC2 instance that will be running in a public subnet, but it's little tightened. You can take out the fat if there are any additional softwares, then take out everything, and then just one EC2 instance will exist in the public subnet just to provide login functionality to your private subnet. That's all. Okay, so you can use your web server also here. You can use your web server as a bastion host also. Pretty much, there's no difference. It's as long as bastion host is a host that you will use it, that's placed in public subnet and you use to connect to instances that are in private subnet. That's all it is. Okay. Bastion host or jump box, right? So, but that's what we did yesterday. But we copied the private key. So without copying the private key, how will I be able to do it? There is a concept called SSH agent forwarding. So there will be an agent sitting in your if you're using Putty, right? So if you're using Putty in your Windows machine, okay, there is an agent sitting there. There is a SSH authentication agent. There is a software called Pageant. Okay, so there is a Pageant software. So what it does is you will add your private keys to that, and now when you're logged in from internet from your machine into this public subnet one, right? What it does is it will not only use your private key to log in, but actually it will forward that. It will forward that key into this one. So it exists in that session. Your private key exists. So you're not physically copying it, because the tool is actually forwarding the private key. And once you are logged in, you will be able to just SSH into it. You don't have to provide your private key there because it is there in the session, because it's been forwarded by Pageant. Okay, and your Mac or Unix or Linux-based machines, SSH agent forwarding is pretty straightforward. The additional command you have to use your SSH. Okay, so I'll provide those Mac commands separately. Okay, but let me show you how to do that in Windows. Okay. So now my objective is, I have a web server here. We did this yesterday. We have a web server. We have a web server in public subnet and another app server in private subnet. Okay, and I copied the private key here, and I also copied the private key here yesterday to actually to log back into this one. I know, just to show you that, right? So let's go ahead and delete that first of all. So let's log in. Let's start with that. So I'm logging into my web server. Okay, I'm logged into my web server. And now, if you look at it, I have a private key there, right? So first what I will do is, first let me go to ec2-user at, let me log into app server once, -i, private key PEM file. Now I'm in the app server. Now let me delete this guy first. Okay, it's deleted. Exit out. Now I'm in web server now. Let me delete this guy also. Yep, deleted now. Now we are in good state. Okay, so you can't use your browser-based SSH. You have to use a proper SSH tool like Putty to do this one. So download a software called Pageant. So Pageant SSH. So see this one, download this pageant.exe. So once you double click on it, what happens is, so it will be running. It will be running as a process as a service in the background. So in your tray, in your application tray here, see here, this guy here. So it will show like this. It's running. So now right click on this and then find out view keys. So what this Pageant does is, it's a authentication agent for Putty. So this is where you can store all of your private keys, and then you can tell Putty to use Pageant, okay, as your authentication agent. And also you can say that please forward these keys into the session. So if I'm logged into a server 1, if I say that please forward it, then it will forward the keys into server 1. Now those keys are available in server 1. They are in the session. You don't see them. I mean, yeah, not directly you will be able to see it. So now you are in server 1. Now from server 1, when you are trying to log into server 2, this keys already there. So you'll be able to log into the server 2 from server 1, okay, without having to copy your private keys. So what you do is, you have your add key, and I have this custom VPC, right? I have this custom VPC PEM file, but it expects a PPK file. So what I have to do is, first I have to convert my PEM file into PPK file. PPK is the one that's used by Putty. So you don't have to do this for Mac, you know that. First, let's open the Partigen. In Partigen, let me load my custom VPC. This is my PEM file, and then I want to load up. I want to save my private key. Yes. And I'll call this as a custom VPC itself, but it will be saved as a different extension, that is PPK extension. Now click on add key, go to downloads, and custom VPC. This is a PPK file. Now I loaded it. Now this guy, this pageant, it's a simple Patti authentication agent. This guy, so rather than loading all these PPK files directly into Patti, you will add them to Pageant, and then Pageant will remember this. Okay, and now you can tell Patti that, just do an agent forwarding. Okay, so open up Patti now. Open up Patti, and then let's go to web server 1 here, and this is my web server's public IP. And here I'll say EC2-user at your public IP, and then go to connection SSH, and then auth. Click on auth, and then see here, allow agent forwarding. When you do authentication parameters, allow agent forwarding. When you allow the agent forwarding, what this pageant is that, see this one, also authentication methods, attempt authentication using pageant. See this one, once this is checked, then it will use the keys that are stored. All the keys are stored in pageant, that's all. That's all you're doing here, rather than going into authentication host and browse, and this is how we have been doing it, right? So rather than doing that, you store all of your keys with pageant, and then tell Patti, hey, pageant will supply the keys for you. That's what this checkbox does. And this checkbox, what it does is, when you connect to this machine, this particular web server machine, please forward the keys. You're asking pageant, because that's the agent, right? So you're asking it to forward it. So now you are logged into your web server. In that session, you have your you have your key available, your private key available readily. Okay, so it's readily available for you. You don't need to do anything.
Venkat?
Yes.
If you have multiple keys, how we are going to differentiate?
So you will add all the keys. Actually, it will forward all the keys, and then they will be in the session.
Okay.
And then as part of your handshake, right? When you handshake happens. So what happens when you log in? When you log in, there is a handshake is happening. Your server has a public key. So let's say you have 5 private keys added to the pageant, and now you'll go from key 1. So you will give your private key 1, and then that server gives the public key, and let's see, it will try to see if a handshake can happen or not. If handshake did not happen, then pageant will give you, okay, try this, my private key 2 now. Key 2 it will try, key 3 it will try. Does it make sense?
Yeah.
So that's what it does. Now it's already there in the session. So all you need to do is sh ec2-user at my private IP. Where is my private IP? 10.0.2.103. That's it. I'm in my private subnet app server. I did not copy my private key anywhere. I did not do any of the non-secured stuff. This is the right way to do it. Now I'm in sudo yum update. I'll not be able to do it because I'm in app server, and app server doesn't have any internet connectivity at this point. So this is called, so in this case, this is called a bastion host or jump box. Okay. So in this case, your web server is acting as a bastion host. you will say that your web server is acting as a bastion host or a jump box to connect to your app server that is sitting in a private subnet. Okay, it's a simple concept. I wanted to mention it. Try that, and now no more copying business. I want you to do that exclusively yesterday because I wanted to feel it. I wanted to show you a way, but I wanted to also show you that that's not a preferred approach. Okay, any questions on that? It's a simple topic. I wanted to put it out there and then move on with the other topics.
Can you log in back to web server again?
What's that? Can you log in back to web server again? You should be able to, but there is no reason for that's little. Actually, that use case is a little.
No, just I want to check whether it's forwarding.
Okay, because you did just the SH from public. Sorry, your web server to app server, right? So that you did not do an agent forwarding from web server to app server. Actually, there is a different command for that. SH agent forwarding command, right? SH you have to do now putty like command. It's called SHA, I believe. Now let me do an exit actually. So now I'm in web server. So I believe you have to do something. Nope. You have to log in slightly differently like this. SH add and then -L. There you go. So this is your this is what you're asking me. You're asking it to list out whatever is there, you know. So now you have to use. Now you want to log in, saying that again. Forward it, please. Please forward the key from web server to app server is what you're asking. So what you want to do is. What's that command? So this is the Mac. This is how you do it in a Mac command. So SSH add L. I mean, this is listing out. Give me all the forwarded ones here. So this is what is helping you log in. So SSH dash agent. SSH, okay, EC2 dash user, is it what it is? Let's find out. So no, I know that's not the one. SSH, oh, -A, there you go. This is the one I was looking for. SSH -A, and then do your this guy. There you go. Now I'm logged in, right? Now let's do a SSH dash add. Give me the list. Okay, now it's there. Now do an SSH. Now EC2 dash user at my public IP. Sorry, I can use private. There you go. So I'm glad you asked, because this gave me a command for Mac people also. So Mac people, what you need to do is just do a simple SSH -A. Like that. SSH minus uppercase A onto your machine. Okay, so from your machine, obviously you will do like this. SSH -A EC2 dash user, like that. And then -i, give your PEM file. So what you are saying is use this PEM file to log into this one, but also forward it is what we are saying here. Understand? So did you guys understand what I did there? So initially when I logged into web server, your pageant forwarded that key to web server. Okay, that's why I was able to log in from web server to app server. But that same key did not get forwarded to app server. But when you do sh-a, then whatever is there in the session got forwarded to app server. So now from app server, I was able to log in back to web server. If that makes sense. Guys?
Yeah, thank you.
So Venkat, the pageant software is not needed for the Mac? I mean,
No,
because
you
we
are
are giving the PEM file. Okay.
You
Thanks.
got. It's not the PEM file though. It's not about the PEM file. It's about SH agent. See here? Here, you're using agent forwarding and you're saying that use this, well, let's say test.pem file, PEM file, right? So use this PEM file to log into this one. Also forward this agent is what you're saying, agent forwarding, SH agent forwarding. So forward the key to the server that I'm logged in so that it's readily available when that particular server is trying to act as a jump box to log into something else. If that makes sense. Yeah.
Yeah, got it. Yeah.
So guys, yes.
Would this be every time or just the first time?
No, every time.
Okay.
Every single time, because you're being secured now. You're not copying your private keys anymore. Make sense?
Yes, Venkat.
Okay. And you are sort of vulnerable only during that session now. Only during that period, your private key is sort of there in the session, but you're not copying the private key. So that's the beauty of it. So your security guys are happy. Okay, that's about Bastion host. If you heard about things like a Bastion host and jump box, they both mean the same thing. Okay, they will help you log into your resources in a private subnet from the resources in public subnet by using a technique called SH agent forwarding. That helps you forward the keys into the box during the session without you having to copy it into the box, if that makes sense. Okay, guys? Fantastic. Now, once that's squared away, we did this one. Now, the current state right now is we are logged into public. Oops. I'm sorry. The current state is I'm logged into web server, EC2-user and then go to, and I can actually save this guy, right? I will save the session. I'll call this as a web server 1, and then I'll save the session. I'll save the settings. I'll go to auth and then say allow agent forwarding and go to session and then save it. There you go, web server 1. And then log in. Okay, now I want to test one more time, and then I'll open the putty and click on web server 1, double click, and you're all set. So everything is set, right? Now let's log into app server using your private key, /ec2-user. I don't need agent forwarding here. I don't want to do it. There you go. Okay, now the problem at hand is I figured out a secured way to log into my private, my EC2 in a private subnet, which is my app server through web server acting as a jump box or Bastion host. I'm all happy. Now, the problem that I want to solve is I don't have internet. My app server does not have internet. Okay, That's the problem. We need to solve it. So understand why this private subnet is not exposed to internet. We don't want to keep them in DMZ. Very fair, and that's exactly how the design should be. But them not having internet to go out and get some software patches or some software from outside, that is unfair. We need internet, one-way internet. We do not want people to come in here, period. We do not want app server to take any traffic from internet. Understood? That's why we kept it as private. Okay, but I need internet to go out so that I can get the security patches or I can get some software. How can I get the internet? So there are two ways you can get it. One is, there is a concept called NAT instance. So NAT, N-A-T, stands for network address translation. So network address translation, what it means is, when you go out to the internet, okay, when you go out to the internet, when this guy is trying to go out to the internet, what this app server is trying to go to, let's say google.com to download some software. Okay. And then what happens is, this network address translation will translate as someone sitting in the public subnet. So when it goes to the router, or when it goes to the router and eventually to the internet gateway, so these guys think that, hey, my public subnet guy is talking to me, not the private subnet one. So this guy will translate the packets that coming from private subnet. That is what this guy's job. That's what network address translation does. So there is a special EC2 instance. You will put it out there with a special AMI called NAT, network address translation. So it's an EC2 instance. We call it NAT instance. It's a simple EC2 instance, but with a special AMI. That guy's job is when someone is trying to go out, this guy will do a network address translation saying that, okay, this guy is talking to me, but I am the one that is sending it out. So this guy will send it as if this NAT instance is sending out. Once it gets the packet back, this guy will retranslate back and then send it to whoever that original requester is. So this guy will sit in the middle as a middleman. Will do the translation for you, or it will mask your request, saying that, okay, so you want to go to google.com. Okay, so let me, when I go out, what this guy will say that is, hey, I want to go to google.com. But this guy will be able to, because this guy is in public subnet, right? So the NAT instance, we will create that NAT instance in public subnet. And then what we will say, private subnet people, we will update the route table and say that, hey, everyone else except the local, please send this to NAT instance. So every single time you try to go out other than your local instances, within VPC, then that packet, that request will go to this NAT instance. This NAT instance will NAT the IP. It will network address translate it and then send the packet out. Once it gets the response back, again, this guy will act as a middleman and then give the packet back to the original requester. Does that make sense? So we will create a brand new EC2 instance in public subnet. And that EC2 instance is a special EC2 instance. Okay, it's called a NAT instance. So there is a special AMI. You can go to the community AMIs and then search for NAT. You will get your NAT instance. Okay, create a new new EC2 instance and put it in public subnet. Now update your route table. Update your route table of your private subnet, and then give a route to your NAT instance. Add a route to your NAT instance for everything else. So meaning, if these guys want to talk to anyone but anyone outside of the VPC, it will go through this NAT instance, and NAT instance will mask it and make it possible. But this is the traffic going out from private subnet. Traffic coming in, there is no route anyway. Traffic coming in, there is no internet gateway attached to this one. So obviously, these guys cannot be reached from internet. So we are fully secured. And at the same time, these guys are able to get the internet from outside. Beautiful. That's in the best state. Best of both worlds, right? That state. And that's where we want to be. So let's go ahead and create a NAT instance in public subnet. It's a simple EC2 instance with a special AMI. We'll go ahead and do that. And then we will update the route table, the default route table, because that's what private subnet is attached to. And then we will give the route out to the NAT instance. Okay, guys. So there are two ways you can do it. One is a NAT instance. So NAT instance, the problem is it's an EC2 instance. There is no fault tolerance there. What if the EC2 instance is down? If the EC2 instance is down, my whole subnet loses the internet connection. That's the problem. Well, again, you can go to the NAT instances using some load balancer, auto scaling group, behind auto scaling group, all of that you can do. You can do that so that your private subnet instances do not lose internet. You can do that, but you don't need to do that. AWS has created a much more resilient approach called NAT gateway. They created this much more resilient approach called NAT gateway. See this one. So you create a NAT gateway in public subnet. Okay. And then you update your route table of your private subnet route table, which is a default route table. So you just say that for everyone else, rather than going through a NAT instance, you can definitely have a single EC2 instance, but single EC2 instance is not resilient solution, because you're depending on one single for the entire internet packets. So if this needs to download several gigs, if I have 200 EC2 instances and all of them need internet connection, and then they're going out, every single packet is going through that single EC2 instance, but the NAT gateway is a fault tolerant, highly resilient, highly available gateway, meaning it's not a single EC2 instance. It will take care of it. And much bigger throughput, up to I believe it's a 10 Gbps. So you will have a much bigger bandwidth, and you almost pretty much you don't have to worry about the bandwidth needs. Okay, so NAT gateway is always preferred. NAT instance is what AWS started with. Okay, and later on they realized the limitations, and now they gave this NAT gateway option. There is no reason to go with the NAT instance now, really. So once you create the NAT gateway in public subnet, but the most important piece here is that either NAT instance and NAT gateway, they must be in public subnet, because these are doing the network address translation. These are the ones that are acting as a middleman, sending the packets out. So that subnet needs to go out through internet gateway. So internet gateway, this guy thinks that, okay, so NAT gateway, okay, it's coming from public subnet. Okay, this guy is trying to go to google.com. Sure, you are allowed to go to google.com. Okay, I'll give you the packet backend, the response backend. And this guy will say that, Because that's the beauty of this, the whole network address translation. It will find out, okay, who was the original requester, by the way? Oh, original request is app server 1 coming from this one. Okay, let me give you back. Because there is a route to NAT gateway. Any questions before I demonstrate this one? Okay, so let's go ahead and do both the ways. First, we will do a NAT instance in public subnet, and then I'll show you a better way to do that. So first, let's go to EC2, because it's a NAT instance is nothing but an EC2 instance. Launch an instance. Go to your search for NAT in AWS Marketplace or Community AMIs. Community AMIs, these are all free. These are all free. So click, you can select the first one here. Amazon AMI, VPC, NAT, HVM, no. General purpose. Okay, and then where do I want to put it? It's not in the default VPC, it's in my custom VPC. And where do I want to put NAT instance? NAT instance must always be in public subnet. NAT instance or NAT gateway, both of them must be in public subnet. Understand that. Their role is to give the internet connection to the private subnet people, but they must be in public subnet. Very, very, very important point. So NAT instance, it's in public subnet, and see this one, use subnet setting. It's not going to assign automatically the public IP, okay? Because your subnet setting is disabled. Ideally, we want to go back and change the subnet setting itself to enable, because the public subnet must have the public IP enable by default. We can go back and change it so that you don't need to, select this one, but we need public IP for NAT instance. Okay. We can leave everything else as is. I'll call this guy as NAT instance. Security group. We can select the WebDMZ security group, but yeah, we can leave the port 22 open to the public. In fact, you don't need to log in also, but just keep the WebDMZ one to view and launch. Okay, it's asking something, boot from general purpose SSD. General purpose SSD volumes provide the ability to burst up to 3000. Okay, to meet, do you want to use general purpose SSD? The default boot volume for all instance launches from the console going forward? No. Do you want to use the general purpose SSD for default boot volume for everything, or make general purpose SSD the boot volume for this instance? Only for this instance. I can even select that. Don't show me this instance. Launch, use the custom VPC, launch instance. My NAT instance is coming up in public subnet. Okay, my NAT instance is coming up in my public subnet here. I know this is gateway, but essentially NAT instance is nothing but a simple EC2 instance. Now, let's go to our route tables. Okay, it's coming up. Let's go to VPC and let's go to route tables. We have a default route table for our custom VPC. The default route table only has that local route. See this one? It only has local route. Now, this default route table is what your subnet association happened. Your private subnet is associated with this default route table, because this is a main route table. So you don't need to do an explicit association. You create 10 subnets, all the 10 subnets automatically get attached to this, the default route table. That is why we did not mess with the default route table. We did not make the default route table a public route table. We did not add an additional route to internet gateway because we wanted the default route table to be very secure. Okay, so let's go to routes, edit routes, add route. Now we'll say o.o.o/o, meaning everyone, and then okay, see that. I just started typing the ID of the instance. See this one, your app server 1, web server 1, NAT instance. So you can there's no magic. It's an EC2 instance. So I'm selecting an EC2 instance. So every single packet going out other than the local one should go through this one, is what I'm saying. If that makes sense. Okay, I did that. Now, one thing we need to do for NAT instance only, this is what Kishore was asking a question earlier. For the NAT instance, what we need to do is, see this one, change source destination check. So I want to disable the source and destination check. So what is the source destination check? So the network address translation, the way it happens is, when a request comes from this particular app server, okay, or let's talk about in general what's happening here, right? So what happens is, see, when I make a request out, I told you this guy, the router here what the router will do is, it will understand it. Okay, this request came from web server 1, okay, and then it will do a network address translation. It will put an additional, this is the source IP. Source IP is coming from web server 1, okay, and then when it writes an additional line there on the packet saying that, okay, I'm sending out as meaning my public IP address, okay, when I send the packet out to the regular internet, my public IP is what will be shown. This is exactly what your router does today. When you send the packet out, internally you may have 10 devices, 10 different IP addresses and everything, but every single one of them will go out and your router orchestrates it. When router sends it, what it does is, it will mask itself, okay, it will put the source address, okay, and then it will add an additional layer there saying that, hey, by the way, when you get the response back, give me the response, okay, and then it will add the source address there. So once I get the response back, my router knows that based on the source address check, now it knows that, okay, this request was originally sent by this Apple TV. Let me send the response back to Apple TV. It does that. So now, but in this case, the NAT instance, we do not want that source destination check. We want to disable that because the original source destination is actually, the NAT is not a regular EC2 instance. The purpose of the network address translation is to do the source and the destination for someone else, not for itself. So when it goes there, what we are saying is, do not do the source destination check because it's going to be done by this AMI within this, because it's going to remember where the request came from and it will add an additional translation for it. So that's why only for NAT instance, please disable the source destination check. So please disable that. After you disable that, make sure you have a public IP for your NAT instance, and make sure you have your source destination checker disabled, and then add this NAT instance an additional route to your default route table that's attached to your private subnet. And now log into your this guy, and now try doing, where am I right now? I'm in 10.0.2.103. You guys know that 10.0.2.103 is your app server, and you should be able to do sudo yum install, sudo yum update, let's say. You'll get you got the internet access now. Beautiful. I'm able to do operating system level patches. If I want to install MySQL on this one, absolutely I can go ahead and do that. Or if I want to install Apache on it, I can do that. Of course, that's not the intention, because this is not Apache. If I want to install Tomcat with Java, absolutely you can go ahead and do that, because that's the original intention. We want to do a Tomcat on this one, so you guys can do that. And then Apache is acting as a front gate. Apache takes the request, and Apache will forward to the Tomcat, and Tomcat will give it back. You can do that. In fact, this is I made that use case up. There is a different way between Apache and Tomcat. There's a couple of Apache modules out there, ModJK and all. But my intention, I hope you got it. So this app server getting the internet now. This guy got the internet because this guy were able to route it through NAT instance sitting in public subnet. Make sense? This is using a NAT instance. I want to show you guys another way. The right way to do it is by creating a NAT gateway. Any questions so far?
So, Venkat, this NAT instance that we created using the particular AMI, right? NAT AMI.
Yep.
What specific software is there for in that in the EC2 instance to do these all address translations? I mean, just out of
it's this is like your network firmware kind of solution. What they do is they act at the layer 4 level. So at the layer 4 level, they take the packet, and so if you guys know the internet traffic, the way it works is that it's like a slip. Let's say you have a small slip. That small slip says that, I'm so and so. This is my IP address, and I want to go to google.com. Okay. So this is my private app server IP, and I want to go to now. Every spot in between, there is a translation happens. Every router check pretty much. So what the next level of router will do it is, right now it's happening in the regular internet. Okay, when you go out, that's what your router does. So what it will do is it will add an additional check saying that, okay, this is keep the original source IP, but I'm masking it. I'm putting myself as the requester now, because I'm going out to the public internet. So let's say now the request went to my ISP, internet service provider. Now internet service provider will put one more layer there. He will say that, I'm the requester now, and send it to some other router somewhere in this, I live in this Metro Detroit area, right? Let's say it goes to the next level of, router somewhere in this Michigan. Okay. The nearest big router, right? So from there to, let's say there is another one in the Midwest, and then another one to, to the entire United States. Okay. Let's say I'm pulling something from Sydney, right? So it goes to another router on the other side of it. He will add some abstraction. Abstraction meaning essentially the packet will have the complete route from my machine to going to the Sydney. It probably have traveled through 20 routers in between. So you will have that information. When a response comes back, So now you're looking at the slip and then say pretty much, okay, who should I hand over this packet to? Okay, it goes to the Sydney guy. Okay, from Sydney to on the other side, New York to pretty much, okay, Ohio to Detroit area. Okay, now it's in Troy. Okay, in this particular router. And within this, it goes to my ISP, comes back to my router, from my router to, again, my Apple TV. So what this particular software does is essentially that it will mask itself, and then it's a network level firmware combination. Okay, so acts at the IPv4 level, at the layer 4 level, sorry, not the IPv4, it's a layer 4 level, and then it will add an additional information, additional source destination check, essentially. Okay, and says that, oh, by the way, I'm the middle guy now. And it will push the original source down and then say that, okay, I'm the NAT instance, I'm the guy. So I need to get the packet back because I know how to, this is acting as a router again. Make sense?
Yeah, got it. All right, thanks.
Yep. It's a gateway.
Hey, Venkat.
Yeah.
For NAT instance, you disable that source destination check, right?
Yep.
So while the packet is received, well, how is it going back to our private subnet? When we are already disabled.
Because NAT does that. Because NAT does that.
Okay.
Because NAT is responsible for that. So so don't do it for NAT instance itself, because that is my job, is what we're saying. I will take care of that. You are not doing, because NAT has that knowledge within that. I will take care of it. So don't treat me like any other EC2 instance. So do not do source destination. Okay, disable all of that, because I'm responsible for that. Does it make sense? So do not treat me like regular EC2 instance. I'm a network appliance, and my job is to do that.
Venkat, on the same lines, right? What someone was asking. So if I have, I'm not using a NAT instance, but I used the EC2 and I have that source destination check enabled. Can it do this same? I know the firmware is not there on the EC2 instance, but is that EC2 instance capable because the source destination checks are enabled? I mean, just asking.
No,
okay.
It's a special piece of software that you have to,
okay.
Yeah, special network appliance that you have to do it.
So can we install that extra piece of software in the existing EC2?
Yeah, absolutely. You can do that. Do I know how to do that? I would say no. But deep network, network specialists, probably they might be, I'm sure they'll be able to do it. Because how did I get the AMI? Somebody took an EC2 instance, installed it, configured it, and cut all the fat and made it solid. And now he created an MSN machine image. That's all it is. So somebody did it, right? Absolutely, you can do it. Make sense?
And yeah, Venkat, thank you. And in case we don't disable that source destination check, what happens?
It will not work.
Oh, the internet connection won't be established. Okay,
exactly.
Got you.
Because it will be treated like any other EC2 instance. And
okay, got it. Thanks.
Yep. So, very good questions. Good discussion. Okay, now, again, I told you the disadvantages of NAT instance. NAT instance is a simple EC2 instance, and there is no fault tolerance, there is no resiliency. If that EC2 instance is down for whatever the reason, this whole subnet will be down. We don't want to be in that situation. My entire private subnet, these guys need regular internet connection out to do security patches and much more than that, right? So I don't want to put them in a DMZ, but they need internet to go out. One-way internet connection is needed. So I don't want to do that. So what I want to do is, rather than relying on a single NAT instance, okay, AWS provided a much more resilient solution called NAT Gateway. So go to VPC and go to NAT Gateways and create a NAT Gateway. And NAT Gateway or NAT instance must be in public subnet. I can't stress out enough here. So this is the public subnet. This is the custom VPC and public subnet. Put this guy here. And then, so elastic IP. So you have to allocate an elastic IP here. You can create it. And then it will automatically create an elastic IP here. And then assign that elastic IP here. Elastic IP is a static IP, right? You need a static IP. It's sitting in public subnet. That's the IP address it goes by. And you can say name. You can say NAT gateway. Create NAT gateway. It's that simple. Okay. Let's give a minute. This is the private IP. So if you look at this one, 10.0.1.29. So this is your, because you set up this NAT gateway in your public subnet here. So it will use one of the pool of IPs for your subnet, 10.0.1.0/24. See this one, 1.29. It used it. And there is a public IP also. Come on, it comes up. So once it comes back, right? Now what we will have to do is go to route tables and go to your default route table for custom VPC, edit routes, take out this NAT instance now completely. And now we'll say that, actually we took out that, right? So let's do a save routes. Okay, first let's make sure that, it's not working. It will break. It will time out. We'll wait for it to time out, and then we will add NAT gateway, and then we will check. It will time out in a few more seconds. And meanwhile, let's make sure our NAT gateway is, it's still in pending state. Let's go to route tables again, default route table, custom VPC, and then meanwhile, edit route, add. I will not save it. So NAT gateway. This is the NAT gateway. So ends with 682951. Remember that? Okay, I got the error. It's trying another mirror. You try several days, nothing will happen. There's no way it's going to work, right? It's getting timed out. It's trying various options, follower, maybe this works, maybe it doesn't know that, right? Okay. Finally, it failed. So now, save routes. Let's make sure our NAT gateway is available now. Yep. Now do a sudo yum update. Simple. See that piece of cake? Quickly, it came back. It went back and checked, and it realized that there are no packages for update for update. If you want to sudo yum install, just for fun. I don't mean to install HTTPD in my private subnet one, but I wanted to show you it works. That's all. Your internet. That's all. So use NAT gateway. Do not use NAT instance. Okay, a NAT instance, NAT gateway, their only sole purpose is to provide one-way internet connection to your private subnet. Period. Fair? And I can safely terminate my NAT instance, because that reference is gone anyway. Okay.
Venkat, I have a question. I know NAT instance is one way, NAT gateway is other way, and NAT gateway basically brings more advantages of load balancing and stuff. Right. So, in general, do they generally use a mixed flavor, like having one NAT instance and other one NAT gateway? I know
there is no reason to use NAT instance now, in fact.
Yeah.
Okay.
Okay.
So they started with NAT instance, years back, and later on they introduced. Everyone did their own, resilient architectures, like a couple of NAT instances, and put the auto scaling group because they are like EC2 instance, right? Okay. Make sure if it's running or not, and then set up your auto scaling group, and then step scaling appropriate scaling policies. All of that, people did it on their own. Then they provided this NAT gateway. NAT gateway, they said that you don't have to worry about resiliency, okay? It's completely fault tolerant, okay? And you have, pretty much you don't have to worry about the bandwidth, okay? Because the point is, NAT instance, T2 micro, that's in our case at least, in our case, we picked up T2 micro. How much bandwidth can it handle? You understand? So the amount of bandwidth you can handle purely depends on the instance type. Okay. But all of that they handle for us. We don't have to worry about it through NAT gateway. Okay. So there is no reason to go for NAT instance now. So that's about NAT instance, and we got we got internet to our private subnet. And how do I log into my instance in private subnet? I think we already talked about it. Yeah, we used SSH agent forwarding, the Bastion hosts, or jump boxes. So that's about major portion of VPC, and I want to talk in depth about this network ACL. Okay, network ACL. We touched it briefly. At this point, all we know is network ACLs, they act as police guards for your entire subnet. Okay. And network ACLs at this point, they do not have any rules, but you can define your own rules to allow the traffic or deny the traffic for specific people, or these guys act exactly like a security group, but security groups are at instance level, but network ACLs are at the subnet level. So let's deep dive into it. It's very important to understand the difference between network ACL and subnet, and there is a couple of deeper concepts there. So I'm going to go over that pretty deep. Okay. So, and then we'll talk about VPC peering and other couple of other theory concepts. Okay. So, what we'll do is, let me pause. We'll take a few minutes break. Okay. So, network ACL. As you guys know, network ACLs sit right in front of your subnet, acting as a guard for the subnet. So these are the rules at the subnet level. So these are numbered rules. Okay, the rules with the numbers, you can say, go from 1 to 100. So you can say rule number 50. You can define that, and then these rules are evaluated in a sequential order. So let's say when someone is trying to reach an instance within that subnet, your inbound rules are applied. When a packet is coming from outside into the subnet, your inbound rules are applied. When these instances within the subnet are trying to reach someone outside the subnet, then your outbound rules are applicable. So when request, let's say there is an HTTP server, your Apache server in an instance, in a web server. So when someone from outside is able to reach here, when someone from outside is able to make a request into the web server, it does not mean automatically that the response will go out. Meaning, you have to define the rules appropriately in your network ACL, both inbound and outbound. So if you define just inbound rules and assume that outbound, it will automatically go back, the response will go back because the request came in and the response will go back, it will not happen that way. Your security groups are different. Your security groups are called stateful, meaning when requests come in, the response will go out automatically, doesn't matter. They are stateful. As long as the requests come in, as long as you take care of the inbound rules, outbound will go out. But that is not the case with the network ACLs. And another difference is the fundamental difference is security groups are at the instance level and network ACLs are at subnet level. And in security groups, you can only put allow rules, but in network ACLs, you can put your deny rules also. If you want to restrict access to a specific IP address to your subnet, then you will be able to do that using network ACL. You cannot deny in security groups. You can only allow. And when you deny it, you have to be careful. Your numbered rules, it's very important that these are evaluated in the ascending order. Meaning if the rule number 50 says that allow traffic, the traffic will be allowed. If you put deny in rule number 51 or rule number 80, then unfortunately it will not be denied because rule number 50 says it's allowed. So I'll allow it. If you want to deny it, put that before 50. Let's take a look at it. So with that said, network ACL is it's an optional layer of security for your VPC that acts as a firewall for controlling traffic at subnet level. When you create a new VPC, a default network ACL is created. I told you guys this one yesterday. We observed that one also. And the default, by default, it allows all the inbound traffic and outbound IPv4 traffic, and if applicable, IPv6 traffic. We looked at that also yesterday. By default, that's the state right now. If you really look at it, we did not mess with the network ACLs yet. If you go to your VPC, see the default even for custom VPC. If you look at the inbound rules, rule number 100, all traffic is allowed. Okay. There is an additional rule with the star, meaning if at all it skips through all the rule numbers here, if for any reason it didn't fall into any of the rules above, then it will fall into the last one and it says deny. But there's no chance here because you are allowing all traffic, all protocols, all port ranges. So coming from all the sources, you are allowing it. It doesn't matter. You're outbound, you are allowing it to everyone, all the ports, all the protocols, all traffic. There are no restrictions. You are allowing to everyone. So this is the default behavior. When you create a new custom VPC, a NACL or network ACL, a default network ACL will be created, and the default, by default, it allows everything. So you can create a new NACL and associate it with the subnet. By default, a new NACL denies all traffic. Okay, that's an important one. So the default NACL is created when you create your custom VPC, which will allow the traffic for everyone. But if you go ahead and create a new NACL here, right? So let's say my custom NACL, network ACL, and then I'll attach this one I wanted to the custom VPC. If I create it, if you go take a look at the custom NACL, look at this one. All the traffic is denied. There are no rules here. Since there are no rules, your default one fall in place, and this one says that all the traffic is denied and all the traffic is denied. Okay. So each subnet must be associated with a NACL. Yes, if you don't specify, the default NACL will be associated. So yes, so the default NACL for your custom VPC, if you look at the subnet associations, both the subnets are associated to this NACL at this point. Both public subnet and private subnet have the exact same network ACL rules, which is allow everything. Okay, now you can change the subnet association, or you can go here and change the subnet association. And one subnet can only have a one NACL association, meaning if I put private subnet association here, then it will be removed from the above. Okay. You can associate a NACL with multiple subnets. Exactly. So you can associate one NACL can be associated with multiple subnets, but each subnet can be associated with one NACL at a time. So if I change the subnet association and move a private here, that private will be taken out here and you will see one subnet here. Just for the kicks, I'll say, let's move the private subnet here. And then you will see now. See, this one is there, and see this one, your default NACL now. This one only has one subnet association, and this one has another subnet association. Your public is here, your private is here. So you can associate only one NACL to a subnet. But the same NACL can go to any number of subnets. See here, one default VPC NACL is assigned to all the 6 subnets. It's just set of rules for your to allow or deny the traffic to your subnet. That's all it is. So NACL contains a numbered list of rules. Rules are evaluated starting from lowest numbered row to determine whether traffic is allowed in or out of subnet associated with the NACL. It's a numbered rules. A network ACL has separate inbound and outbound rules, and each rule can either allow or deny traffic. So both the inbound and outbound. So we created a custom NACL, right? So let's go to inbound rules. And at this point, all the inbound traffic is allowed. Okay. And I can say that rule number 100, custom TCP rule. What port do we want to allow? Let's say I want to allow port number 22 to everyone within the VPC. If I want to say 10.0.0/16, so everyone within the VPC, I want to allow port 22. Okay, so it means inbound is allowed, right? You have to have the corresponding, because the packet will come in, but it will not go out unless you put this one in the outbound. Okay, you must have the outbound rule. So the corresponding outbound rule. We'll talk about ephemeral ports in a minute, but essentially you need to have the corresponding outbound rule. Okay. I'll talk about the corresponding outbound rule in a minute, but the packet will come in does not mean that packet will go out. The request come into subnet does not mean the response will go out. The response will be dictated by the outbound rule. Make sense? So now, if I want to allow port 22, meaning I want everyone within my VPC, to be able to log into my private subnet group, okay? But except one of them, let's say. I can add rule 110, let's say, custom TCP rule, port number 22. Let's say 10.0. Let's see who is my public web server. Where is my public web server? I want to deny just to this web server. This is my private IP. /32. If I want to a specific IP, then you have to do a /32. Okay, /32 means it's only one IP. So now here I can say deny. Okay, now tell me, this is an important aspect in the exam and real life also. Do you think this? Do you think this will be denied when you try to SSH from this box? Will this be denied? Because
it is more than 100, right? So it should be less than
exactly
100 to apply.
Because it goes from 100. Rule number 100 says that. So your IP is one of the IPs within this broader set here in this IP range 10.0.0.0/16, right? So your specific IP is one of them, and it says that yep, this source port 22 is allowed. I'm sorry, this doesn't even get executed. It doesn't even come here. As soon as I allow it, it's allowed. So if you really want to deny something, you have to reduce it to a lower number. And why did I put 190 like that? Why not? Why didn't I put 100 to 99? Because I'm giving some space so that next time when things go change, I will have some space there. 95, rule number 91, rule number 92. If I want to add any rules between these two, I will be able to do that. That is why I'm going by 10 by 10. In fact, that's what AWS documentation also, they kind of recommended. Okay, so that your future, you're taking care of your future. Okay, so network ACLs are stateless. Understand that point. Network ACLs are stateless, which means that responses to allowed inbound traffic are subject to the rules for outbound traffic, meaning a packet or a request coming in after inbound rules are allowed, it does not mean that the response will go out. No. You have to, your outbound rules will be evaluated when the packet goes out. Since outbound says that deny, it will be denied. So that means request is successfully able to come in, but it's not going out because it's denied. So you have to take care of both inbound and outbound rules. So it's very stringent. It's a stateless. Okay, but your security group is not stateless. It's a stateful. You only take care of inbound, and outbound will be taken care. NACL rules, evaluated from lowest number rule to highest. As soon as a rule matches traffic, it's applied regardless of any higher numbered rule that might contradict it. Rule number 100 matches it, meaning I will allow it. Even if rule number 110 says that deny it, I don't care. Because it does not even get executed, because rule number 100 says it matches, absolutely, let me go, allow it or deny it. So that's why it's important. Each network ACL also includes a rule whose rule number is an asterisk, the last one. This rule ensures that if a packet doesn't match any of the other numbered rules, it's denied. You can't modify or remove this rule. Yeah, absolutely. So that's a default one. If somehow slips through all the above rules, then it goes to your asterisk. And your asterisk says that deny to everyone. So NACL rules examples. Let's take a look at it. Let's say you wanted to deny an incoming traffic from specific IP. Let's say 16.32.167.4. You added a new rule 110 to deny the traffic from that IP. Rule number 100 already exists. Take a look at this one. I just mentioned it already. So rule number 100 says that allow TCP, 80 rule to everyone. To everyone. See here, guys. It's this one says that source is everyone. So allow it to everyone. Port 80, allow it to everyone is what rule 100 says. But rule 110 says that deny it to this specific IP. Deny it to specific IP. Then your 110 doesn't even come into picture, because your 100 rule got it got matched, and it will allow it. So there is no effect. Will traffic be denied from this IP? You should expect a questions like this in the exam. Will the traffic be denied? Nope. Traffic will not be denied because your rule number 100 is lesser number, right? Nope. Since rule number 100 says allow all traffic on port 80, rule number 110 will be ignored. The rule number should have been below 100. Absolutely. Did I make sense there? Guys, make sense? I think it's pretty straightforward. Okay, so now let's talk about something else called ephemeral ports. Ephemeral meaning temporary, short-lived ports. It's a short-lived ports. Let's understand this example. You have a laptop device, okay? And you are sending a request to a web server. This web server is running on port 80. It's listening on port 80. Okay, your HTTP server is listening on port 80 and you send a request to port 80. And I want you to think and understand here. So this guy is listening on port 80. Okay, then this guy is sending a request to the web server on port 80. So before it reaches, there is a subnet here, and your subnet rules, your NACL rules will come into picture. And NACL says that NACL's inbound rules get applied when the request is going into. NACL's inbound rules will come into picture. Okay, looks like port 80 is allowed to everyone. Very good. So I will let you talk to it. The request went to the web server. Web server responds back. Web server responded back with some HTML, let's say. But again, NACL come into picture. NACL's outbound rules come into picture. If you put port number 80 on the outbound side, okay, it will allow the response to be written to your laptop device on port 80. So what I want you to understand here is that when this guy sends the request, it doesn't use the same port as your web server. If this guy has a web server, some Apache running here, listening on port 80, that's different. But here, every single request coming from this laptop device or your iPhones or any of their Apple TVs, they will open up an ephemeral port, a temporary port, a short-lived port. And then on that particular port, it will make a request and it expects the response back in the same port. Let's say in this example, it is sending this request on port 50,000. It opened a port 50,000 port, okay, and then sends a request to this guy. Where does the response to be written back? Is it port 80 or port 50,000? You have to give the response back to the source on port 50,000. So that's why the port 50,000 must be open on the outbound. So on the inbound, port 80 should be open from everyone. But on the port outbound, if you open 50,000, then the response will be written back. But let's say this guy is, but these are ephemeral ports. These are not constant ports. These are temporary ports, okay? Every device has some temporary ports. So Microsoft Windows uses certain port ranges and Linux uses certain port ranges when they make outbound calls. And your iPhone, you have your Mac, Unix operating systems. Everyone has their own range of IP addresses. Range of ports, I apologize. Range of ports, ephemeral ports. So these ephemeral ports are temporary or short-lived ports. They get used when they send a request to something. Okay? They open a short-lived port there and then send the request from that particular port, and it expects the response back on the same port. So if you want your response back to be returned, your NACL should allow for these ephemeral ports on the outbound is my point. Meaning for this to work, okay, for this web server request to work, you have to allow port 80 from everyone or from this particular laptop device for this particular IP, port 80 on the inbound side, but on the outbound side, you have to open for these ephemeral ports, whatever those ephemeral ports are. In this case, in this example, it's 50,000, then allow just 50,000 if you know that it's just 50,000, but the next request could be coming in a 55,000 port number. Because at that second, at that millisecond, whatever the port it's open, it will keep, every operating system will keep certain port ranges. Okay, and then it will open one of the available ports at that second, and then send the request, and then it expects the response back. So that's why you have to give the range of ports when it comes to outbound ephemeral ports. On the way back, on the outbound, your NACL rules should have ephemeral port range. Is a one sentence if you want to put it. So here, web server is listening on port 80. Destination port is 80. Every client uses a different ephemeral port to send the request. Expects the response back on the same port. Yes, in this case, it's 50,000. Ephemeral ports are short-lived. After the response is received, port will be closed on client machine. So in this particular case, it's a port 50,000. It's open, made a request. Once it gets the response back, that port will be closed. Now, when you have to make an additional request now, when you have to go to somewhere else, let's say google.com, then it will open a brand new port and then send that request to google.com on that port. Google.com may be listening on port 80. or 443 HTTPS, depends on HTTP or HTTPS. But it expects the response back to be written on the same port in your device. For the next request, the client could the client port could be completely different. So we need to open the port range. Exactly. So this is your inbound rules. What you are saying, ephemeral port in this inbound rules, right? Your web server, you have a web server. You are saying allow port 80 to everyone. Allow port 80 to everyone is what you're saying. Make sense here? But your outbound should say that rule number 100 or whatever the number it is, and the custom TCP rule. And then here you gave some port range here, 32,768 to 61,000. Okay. And this is one range. So this is one typical range that kind of covers your majority of the Windows and Unix, Linux ephemeral ports. So you are opening up the port range for everyone to write the response back to those client machines. Okay, these ranges could be different for different clients. Your Windows, before Windows 10, Windows was using all the way from 1,000 till 65,000 port ranges. Now they actually reduced it to now 50,000, I believe, to 61,000, somewhere in that.
Hey, Venkat.
Yes.
So what's the advantage for this when a device changing these ports frequently?
So what's the advantage? So, so you need a port. You want to send a request out, right, to a web server, okay? Or when you make an SSH or HTTP or something, right? So it needs a port, okay? And it wants to use the ports that are not being already used. Let's say, web server is running on 800 and your Oracle is running on 1521 on your laptop, let's say, okay? Your Tomcat is running on 8080 Oracle is running on 1521. Your MySQL is running on 3306. These are all the ports, right? So now you need a port. So for when you make a request, you need a port, because to uniquely identify your machine, you need an IP address. Across the 10 devices, how do you uniquely identify it? Using your IP address. Within that, there may be 10 processes running. How do you identify 10 processes? How do you differentiate this 10 processes? Using the port. So let's say there are 100 things going on within your machine in the background. There will be 100 ports open. Make sense? So at any time you can look at your ports using these commands like netstat minus ANO. So these are all the ports that ports being open. So there are 49,000. See this one? This is a UDP port. 49,895, 49,896. So there may be, see this one, these are all the ephemeral ports, something it sends a request somewhere. So there may be some process running in the background. Okay, it could be your it could be your security scan. Are you making your Chrome browser something add request in the background? So these are all the TCP ports running on your local machine. See this one? These are all the ephemeral ports. So this may be going out to, this is in a closed wait state though, but these are all established. See this one? These are 56,000s. So when you make any HTTP, any TCP or UDP call, forget about HTTP. HTTP is a little abstract, but lower level, you have TCP and UDP. Any request, you need to open a port, and on that port, you'll make a request, and on that port, you listen. Okay? So there's some connectivity established on this particular port, and there is something going on, some activity, meaning it made a request to something, a google.com or Google your ad, Google AdSense or something that's maybe working in the background. That may be this guy. Understand?
So let's say I'm doing a just simple browsing from a Chrome browser. Mm-hmm. So does the ports change frequently, or
absolutely
is it only the same?
They will. They will for every single request. This is at the operating system level. It's nothing to do with your Chrome. Understand?
Yep, got it.
Yep.
Go ahead. In this slide, actually, I think see in the inbound rules we are allowing the port 80, right? And this in the outbound rule, I think we are only specifying the ephemeral ports.
Exactly.
But we are not specifying the port 80. Is that fine?
Fantastic question. Yes, that is totally fine, and that's how it should be. The reason is you may be. I'm really glad you asked. So I wanted to mention that. So it's very tempting for you to say that port 80 should be in your outbound rules. Right? Port 80 also. But understand here, this guy, this laptop here, or this iPhone here, when it made a request here, this guy is not making that request on port 80. I want you to understand that. This guy is listening on port 80. It doesn't mean that this guy is making a request on port 80. No, port 80 actually, it's port 80 is reserved for Apache. I mean, there may be an Apache running here, and he is listening for other clients. You understand? But when you make a request, it uses ephemeral ports of that operating system. So on the outbound, yes, you do not need to mention port 80. You do not need to. Just mention the ephemeral ports. That's it. Because you have to be able to successfully write the response back to the devices, whatever the port, ephemeral port that's open. You do not need port 80. Did I make that clear?
Yeah, and one more, that the follow-up question, Venkat. Let's say, like, I'm using another web server and calling to the other web server. Let's say my both web servers are running on 8080, but they are on different machines anyways. So in that case also it does same, right? It just opens up the ephemeral port and then calls the
exactly every single one of them. Every single, right now these many ephemeral ports are open. If there are any active connections going on here, when I make a request here, or any of the process, these many ports, these many TCP ports are open. These are all the ephemeral ports that some of them are actively established, some of them are close wait, and every time it changes. Every time it changes based on the state at the time. Make sense?
Yep. Yes, Venkat. Thank you.
Yep. So, good questions. Yes, you do not need port 80 here. Just allow the ephemeral ports. Your inbound ports are important for the packet to come in. The outbound rules are important to be able to write back the response to your clients. Whatever the ephemeral port that they kicked off the request on, we have to be able to write the response back.
So does the same thing apply to SSH port 22 as well?
Absolutely. Because port 22, you're opening on the destination machine. That's a good question. Okay, here you have your port 22 open. It doesn't mean that this is the port 22. Okay, you have an ephemeral port open, and then this guy is listening on port 22. Important point. Okay, so security group versus NATO or network ACL. It's an important concept going into the exam. In general, also it's important to understand it. Security group, it operates at the instance level. Network ACL operates at the subnet level. Security group supports allow rules only. Now with this understanding, go back and mess with the security group more. Try to see if you can deny anything. Can you deny a specific IP address using security group? Nope. So where it really helps is in the exam, when you have this multiple choice, right? So you can clearly avoid the red herring. So he will somewhere says that you can change your security group to deny particular IP. Then you know immediately that is not possible. So go to the next answers. So to eliminate the eliminate the wrong answers, right? So use this knowledge. So network ACL, it supports allow rules and deny rules. We looked at it. It allows and denies. Okay. And security group is stateful, meaning return traffic is automatically allowed regardless of any rules. Return traffic is automatically allowed. Even if you delete the complete outbound rules, still it is allowed. Once the packet come in, it will go out, period. But network ACL, no. Return traffic must be explicitly allowed by rules. If I close that, or if I delete that ephemeral rule in my outbound rules, then it will not work. The request went in, but the response is not coming back. All rules are evaluated before deciding whether to allow traffic. This is an important point from security group perspective. All rules are evaluated, combined together, and then it decides whether to allow the traffic or not. But here, rules are evaluated in a number order when deciding whether to allow traffic. If rule number 100 allows, it just allows it. It doesn't even go to the next rule. Security group applies to an instance only. instance only if someone specify the security group and launching the instance or associate the security group with the instance later on. It applies to an instance only. If someone specifies the security group and launching the instance. Yeah. So essentially what it means is when you create the instance, so you will be specifying for that particular instance security group. Okay. You must specify the security group as part of your creation of your instance. Okay. There is nothing that's automatically get assigned, but in network ACL, it will automatically applies to all instances in the subnet that it's associated with. So you don't have to explicitly specify anything. Okay, there is a default NACL, right? Default NACL, default network ACL. So when you create a subnet, this default NACL will automatically be associated with all the subnets. So the rules get applied automatically. So it's an additional layer of protection for your subnet. Okay. So yeah, this is an important diagram that I picked up from AWS documentation. Take a look at this one. Oh, sorry, it's not AWS documentation. It's from IBM. So I gave the credit to these guys, IBM. So look at this one here, guys. This is a VPC. And I've been telling you about this internet gateway here, right? So all the internet traffic will come through the internet gateway. Okay. But there is something else called virtual private gateway. I will talk about this one a little later. But internet traffic will come in and then gives it to the router. This router always reads the rules from the route table. Okay, you have the route tables here. So if there is a route, then it will give it to the network ACL. Network ACL is a police guard in front of your subnet. This is your subnet. And once it enters into the subnet, before it hits your instance, your security groups are applied. And same thing on this side. Okay. So, but the traffic could come into this VPC in two different ways. One is the regular internet gateway. The other one is virtual private gateway. Virtual private gateway, if you have your own data center, your office data center and your public cloud, you will establish a VPN tunnel between those two data centers. And virtual private gateway is AWS side of the VPN tunnel. So VPN tunnel has two parts. One is on your data center. The other one is on the AWS side. This virtual private gateway is on the AWS counterpart. So the traffic coming in from your own data center through the VPN tunnel, it will be received here through virtual private gateway. But essentially, it doesn't matter whether it's an internet traffic or your own VPN traffic. It doesn't matter. They eventually be given to the router and all of your route tables, network ACL, security group instance, all of these rules, all of this, everything is same. But it could be coming in from direct internet, or it could be coming in from your VPN tunnel. Just put this bigger picture in the mind. These many components are there when it comes to VPC, virtual private cloud. So it's very important to understand that. So before we talk about VPC peering, I want to mention, let's go back to network ACL. So what we can do is we can have some fun with the network ACL. So what I want to do is, first let's go to EC2. First, let's go to EC2. This is my web server 1. Let's go connect to it. And let's make sure your HTTP server is running. Looks like it is running. This is my public IP. And can you guys quickly test it from your own machines if you're able to log in? I'm sure you will be able to log in, everyone, but I just wanted to Share it. Okay, that's fine. 52.23.237.97. That's the IP.
Yeah, we are able to access. Yeah.
Wonderful, wonderful. Okay, now what we'll do is, let's. This is in public subnet, right? This is in a public subnet. So let's go to VPC. Let's go to public subnet. This is your public subnet. So public subnet, what's a network ACL? Network ACL is your default NACL. Okay, so default NACL, and it says that allow all the ports to everyone. Allow all the ports to everyone. So what I want to do is now, let's go to NACL, network ACLs here. So in custom NACL, I'll rename this guy to, no, I'll create a new one. I'll call it public subnet network ACL, and my custom VPC. So this is public subnet, right? So what I will do is currently there is no subnet association. What I will do is I'll change that subnet association. I will add my public guy. Okay. So if you look at it, the default NACL has got no subnet associations, my public subnet. So what are the inbound rules? Deny everybody. Your asterisk, deny everybody. Now can you try going into these?
Yeah, it's spinning actually, no response.
Exactly. You will not get any response because traffic is not allowed into this, into subnet, right? Makes sense. So now what we'll do is I'll go to inbound traffic and then say rule number 100, port number 80, allow to everyone. Save it. Now can you refresh it? The request went in and the response is not written back. The response is not coming back. Request allowed, okay, but it's not coming back. So it's the same behavior, right? So what we'll do is let's go to outbound rules, edit outbound rules, add rule number 100, and custom port range 32,768 to 61,000. It's a general range. Allow it to everyone. Save it. There you go. Within a second, I got the response back. Now keep. Can you guys, all of you, try? It should allow you now.
Yeah, it is working.
Kishore, I think you're asking the question, should I put port 80 here, or ephemeral ports is enough? Ephemeral ports is enough because client is not listening on port 80 anyway. So I'm able to write back. So now let's use the magic of NACL. So I want to, what is my public IP? What is my IP? This is my public IP. Come on. What's going on? Okay, this is my public IP, 6914 something. So what I will do is I will add rule number 110 and I'll say the port 80 must be denied to this guy /32 if you, since you know precise IP address. Okay, and now I will, there's no effect, right? I'm doing a Control-Shift-R, meaning I'm doing a hard refresh to see if it's a cached. Nope, it's still I'm able to go.
Venkat, you said allow, you have to say deny.
Oops, I'm sorry. Thank you. Good catch. Good catch, good catch. Okay. Nope, there's no, I keep refreshing here, no effect. Now what I will do is I will change the rule number to 90. Okay, and then save it. Now it will keep spinning, but it will keep spinning only for me. All of you guys should be able to access it. Can you verify that for me?
Yeah, it is working for us. Yeah.
So everyone, it should be working for everyone except me, because I have denied it for myself. Yeah, you got the error already. Make sense? Now I'll take back. Let's say I don't mean to. I meant to delete this 90 and then go back, just refresh it. And when you change the NACL rules or when you change the security group rules, the effect is immediate. You don't have to reboot anything. You don't have to do anything, nothing. Because it's a security. It propagates immediately. It happens instantaneously. Understand that going into the exam also. That's about NACL. Okay, an important concept. Okay, that's about the network ACL, security groups, and now you can go back and play with the security groups. I know you guys have a lot of experience in it. You can go back and change. There is no deny rules here, only allow, right? And you can go back to outbound rules, delete this complete outbound rules, but there is no effect. There is no change because these are stateful rules. Okay, once the traffic is allowed, it will go back. Packet come in will automatically go back because security groups are stateful. Understand that going into the exam. Wonderful. So we talked about VPCs, right? So undoubtedly the most important aspect in the exam, undoubtedly, you can expect out of 65 questions, you can expect anywhere from 6 to 10 questions on VPC area. Okay, so it's more than 10% or so. 10 to 15% you can expect. Okay, so there is another concept here called VPC peering. So let's say you have a VPC A, and VPC A has this IP range of 10.0.0.0/16. And let's say VPC B has a completely different IP range, 172.13.0.0.0/16. So there is no collision of IP addresses between these VPCs. If there is no collision of IP addresses between these VPCs, okay, what you can do is you can do something called VPC peering. You can peer both the VPCs, and once you establish the connectivity, once you do the peering between these two VPCs, you can feel that all of this is running in a single VPC. Pretty much, I'll be able to log into these guys as if I'm in the same VPC. So these private IP addresses I'm able to see these private IP addresses, and these instances will be able to see these private addresses. So as if they're in the same VPC. Of course, all of your route tables, all of your network ACLs, security groups, everything will come into picture. All of them will come into picture, but they'll be able to see each other, okay, as if they are in the same VPC. That's the beauty of it. So a VPC peering connection is a networking connection between two VPCs that enables you to route traffic between them using private IPv4 addresses or IPv6 addresses. Understand this, private IPv4. That's only possible within the VPC typically. But when you have the VPC peering, then you have, using the network magic, you will be able to see the other VPCs also as if they were in the same VPC. Instances in either VPC can communicate with each other as if they are within the same network. You can create a VPC peering connection between your own VPCs or with a VPC in another AWS account. This VPC A can be my account and VPC B can be your account, and both of us can do a VPC peering. So VPC peering typically can be used in the case of departments. These departments have a different VPC, and this department has a different VPC, and you'll be able to do a VPC peering. Or when you're working with your vendors, some partnering companies, they have their own VPCs, but they will expose that. You can do a VPC peering between those two, so that you can do the VPC peering, so that you will get the impression that it's the same network. Okay, you can use that technique for your partnering companies. It can be in a completely different account, okay, or other departments you can use it. And if you have a VPC for QA environment and VPC and prod environment, I don't see a reason why you need a VPC peering, and you don't want to have it actually. I'm just throwing out some examples. So the VPCs can be in different regions, also known as inter-region VPC peering connection. So that's the beauty here. So the VPCs can be in a different regions also in the VPC peering. The only consideration here is that there should not be any IP collisioning between these two. If this VPC B also has 10.0.1.0/24, let's say, then the peering will fail. Peering will fail because there is a collision in IP. 10.0.0/16. Here I'm saying 10.0.1.0/24, meaning this is a subset of this superset, right? /16 is a superset, and /24 is a subset. And this 1.0 is part of this guy. So there is the peering will fail. Okay, as long as there is no IP collisioning, VPC peering is possible. And the most important point here is this line here. Transitive VPC peering is not allowed. Understand that, please, going into the exam. Meaning, VPC A has peering to VPC B. Let's say VPC B has peering to VPC C. Then it may be tempting to think that transitively A will have a peering to C. Nope, you will not. A has peering with B, B has peering with C, but A does not have peering with C. Transitive peering is not allowed. If you want a peering between A and C, then you have to have an explicit peering between A and C. But you cannot have a transitive VPC peering. Understand that, please, going into the exam. So that's about the VPC peering. And I also talked briefly about virtual private gateway. This virtual private gateway is Amazon's side of VPN connection with your data center. Virtual private gateway is Amazon's side of VPN connection when you have a VPN tunneling between your data center and AWS cloud. That is your virtual private gateway. So when you're establishing a VPN between both the data centers, you will set up your virtual private gateway. And that is why I was saying, to your VPC, there could be two entry points. One is your internet gateway or your virtual private gateway. Either of them, it can go either of them. So, and between two data centers, let's say you have your own data center. This is Amazon, one region. You have your VPC and all, and this is your network, your own data center. Okay. So how can I establish connectivity from my data center into AWS cloud? There are two ways you can achieve it. One of them is called VPC tunneling. The one I said, with VPC tunneling, you will have this virtual private gateway, and virtual private gateway is it's the AWS side of VPN connection. Okay. There is another option here called AWS Direct Connect. So with AWS Direct Connect, what happens is this is your data center and this is Amazon's data center. What you do is you put your router somewhere in a location closest to AWS cloud. You put your router here and Amazon will put their own router. Okay. There is something called AWS Direct Connect location. This location could be your own region. Let's say there is Ohio, right? So Ohio, there are some AWS Direct Connect locations. So you put your physical router there and they will put their physical router. These are physical routers there. And then once you put it, then pretty much you are establishing a dedicated connection from your own data center into AWS Direct Connect. So AWS Direct Connect is a great way to reduce the network latency, and because it is not using your regular public internet backbone. It is using dedicated network between your data center and AWS. That is the beauty. So you will have predictability with your network traffic. But it's expensive, very expensive also establishing, and you need to sign the contract with AWS first, and then you may not have a router in this AWS Direct location. How do you do that? In that case, AWS has this concept called APN, AWS Private Partner Network, AWS Partner Network. There are a lot of partners out there. Okay, a lot of companies, they partner with these vendors, APN, AWS Partner Network. So they will have all these partners, they will have their own routers. So you work with them and then they will help you establish from your own data center to their router. After that, their router will be connected to the AWS router, and from AWS router to all of this one, they will have a dedicated line here. They will have a dedicated line and they'll go through this virtual private gateway and then all of this one. And very less latency because there is no internet. It doesn't go to the internet regular route. It's a dedicated line. Much faster, but it's a big bill. It's a tens of thousands of dollars. So it's pretty expensive deal, but it's a lot of companies they opt for it because their entire data center hasn't been moved to cloud. They have some in their own data center, and then they are in the transition mode to move to cloud. Then have a AWS Direct Connect so that you will have a predictability in your network, and you're not going to the public internet, and there is no security aspects, nothing, because it's a dedicated channel. It's just for you. Make sense with the AWS Direct Connect?
Venkat, one question regarding the VPC pairing. You did mention that different region, different AWS accounts, but how about a different VPC for, let's say, Google or any other cloud providers? I mean, does it support or it doesn't?
It does not. No.
Okay.
No.
Okay.
It's a cloud provider specific, Nisla.
Okay, gotcha. All right,
Okay.
thanks. Yeah.
Oh, by the way, I'm glad you asked. Actually, the entire VPC concept. Actually, I'll take back. Not only entire VPC concept, all the concepts that we have been learning, right? Most of them are cloud provider agnostic. All of them exist with Azure, same with Google Cloud Platform, same with Oracle Cloud, same with IBM Cloud. Seriously. And by learning, with me here, this AWS concepts, you are not only learning for AWS, you are just expanding your knowledge base in general here. These concepts work exactly same in Azure also, Google Cloud Platform also. The names could be different. Only the names are different. Okay. So there is another concept called VPC endpoint. Okay, so you have your private instances in your private subnet, right? So, and we looked at our app servers are in private subnet. Our web servers are in public subnet, app servers are in private subnet. And to get them internet connectivity, you can have either NAT instance or NAT gateway. We understand NAT gateway is better than NAT instance any day. Okay, so let's say this private instance, this app server wants to connect to S3. And S3 is a publicly available service. It's public internet. Okay, but I don't have internet connection. Well, you have two options now. Well, if you want one-way internet connection, you can have you can have your NAT gateway in your public subnet, so that, and then update your route tables so that you will get the internet connection and you'll be able to connect to your S3. Beautiful. That's one way to skin it. The other way is you can use the VPC endpoint. All you need is just connecting to some AWS services like S3 or DynamoDB, etc. Create a VPC endpoint for your S3 or DynamoDB or some of the supported services, and it does not use the regular internet traffic. It uses just your AWS internet linking. It doesn't go out of your Amazon network, and you do not need any NAT devices, any of your NAT instance or NAT gateway or VPN connection, direct connect. You don't need any of it. You just create your VPC endpoint. Just because these are AWS services like S3, like DynamoDB, okay? You just create an endpoint and use them magically, and you can't connect to anything else. There's no internet connectivity, but you'll be able to connect to the S3 bucket and be able to add objects into the bucket, get objects from the bucket, or delete objects from the bucket. All of that you will be able to do that with the concept of VPC endpoint. It's beautiful. Okay, so your private instance, so it lets your private instances connect to supported AWS services like S3, like the DynamoDB, etc. No internet gateway, no NAT device, no VPN connection, and no direct connect. Magically, you'll get it. Okay, you will not be able to connect to any other systems, but only to the VPC endpoints. So private instances do not need public IPs. No, because it doesn't leave the Amazon network. Traffic does not leave Amazon network. They do Amazon's own magic, and then network magic, and then they will make it visible, and you will be able to talk to S3 bucket. You'll be able to go talk to your DynamoDB and more. Their supported AWS services are there, and without losing any of your security considerations, without having any internet gateway, NAT devices, any of that, you'll be able to connect to it. That's the VPC endpoint. And I have a homework there for you guys. So create a VPC endpoint for your S3 bucket, and then use them. See if you are able to connect to it from your private private instances and private private subnet.
So Venkat, with this VPC endpoint, I understand S3 bucket is good example. DynamoDB, such kind of database, they need updates, software updates and everything, right? And like versioning updates. So those, they might not get it because it's a VPC endpoint. And internet connection is not available, right?
Sorry. I think concept was misunderstood. Let me step back here. So the point is,
So I think what I understood was we are not making our private subnets go through our NAT gateway, but instead the private subnet resources want to talk to any of the Amazon services like S3 or any other thing, then VPC endpoint is the way. But for that, but internet connection and all those are not the ones that we want to address here, right?
Yep. Take a look at this one. This is an S3 bucket. Let me make sure I know. This is an S3 bucket, okay? So this is an S3 bucket, and you create a VPC endpoint. You create a VPC endpoint, and with your VPC endpoint, these app servers will be able to connect to S3 bucket without needing a NAT gateway or anything else. So these guys still do not have internet connection. These guys still do not have internet connection. This S3 bucket is somewhere in the public internet, right? Because being, someone else, let's say, from your home, somewhere here, you'll be able to connect to this S3 bucket. S3 bucket is publicly available, right? But this guy doesn't go to public internet. Generally, if you don't have a VPC endpoint, when you try going into AWS CLI or through your REST API or through your SDK, if you want to do to S3 bucket, from here, you have to somehow go into this one, right? How can you go without having an internet connection? With the NAT gateway, yes, you can go. Absolutely, I understand that. But without having a NAT gateway, this is the only reason I'm using NAT gateway. I don't need NAT gateway. All I need is to go to S3 bucket. And S3 bucket happens to be part of your AWS ecosystem. Can something happen? Can I do something about it without needing NAT gateway? Well, yes. Create a VPC endpoint, and through endpoint, you'll be able to go. So using this, since this is also in Amazon own network, rather than going in the public internet route, if you want to go to public internet route, unfortunately, this guy can't go because there's no internet gateway or NAT gateway or VPN or direct connect, right? So you don't need to go. Just specify your VPC endpoint and go through that VPC endpoint and go to your S3 bucket. Did I understand? Did I make that clear now?
Yeah, this is very clear. With the picture, it makes sense. Yeah. Okay.
Right.
Gotcha.
Right.
Yeah.
So my point is same way with the DynamoDB. So DynamoDB is also sitting here somewhere in the public internet. Okay. If you want to connect to these guys, go through the VPC endpoint from your app server. Is my point.
Yeah. Thank you, Venkat. I think this is
good. Yep. I'll probably make one slide for that next time. Okay, guys. So that's it. Pretty much that's VPC. Undoubtedly the most important section. So now let's talk about the homework, and we'll go from there. Let me stop recording.